Day 718 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1722, minimize Hamming distance after swap operations. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given two integer arrays, source and target, both of length n. You are also given an array allowed swaps where each allowed swaps of I is equal to AIBI indices indicates that you are allowed to swap the elements at index AI and index BI, zero index of array source. Note that you can swap multiple elements at a specific pair of indices multiple times and in any order. The Hamming distance of two arrays of the same length, source and target, is the number of positions where the elements are different. Formally, it is the number of indices I, for 0 is less than or equal to I, and I is less than or equal to n minus 1, where source of I does not equal source of target, 0 index. Return the minimum Hamming distance of source and the target after performing any amount of swap operations on array source. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input source equals an array of integers 1, 2, 3, 4, target equals an array of integers 2, 1, 4, 5, allowed swaps equals a 2D array of integers, first one being 0, 1, then the next one being 2, 3. The output is 1. So let's take a look at the explanation to see how they got this output from this input. So the first thing I'm going to do is I'm going to just copy and paste this over here so we could go through it. Boom. So it says source can be transformed the following way. First, we'll swap indices 0, 1. So that comes from this allowed swaps right here. We're going to swap indices 0 and 1, and source becomes 2, 1, 3, 4. So we can swap this. That's a 1. And that becomes a 2. Boom. Then we can swap indices 2 and 3, and source becomes 2, 1, 4, 3. So then we'll swap indices 2 and 3. So this becomes a 4, and this becomes a 3. Boom. Then after those swaps, the Hamming distance of source and target is 1 as they differ in one position, index 3. So as you can see, after those swaps, this source starts with 214, target starts with 214. The only place that they're different is right here, index 3, because that's a 3 and that's a 5. But since they only differ at one position, that means they have a Hamming distance of 1, and that's why our output is 1. Now, just in case that didn't make sense to y'all, let's take a look at example 2. So in example 2, our input source equals an array of integers 1, 2, 3, 4. Target also equals an array of integers 1, 3, 2, 4. And allowed swaps is a blank array. This time the output is 2. The explanation says there are no allowed swaps, as you can see, because we have a blank array. The Hamming distance of source and target is 2 as they differ in two positions, index 1 and index 2. So as you can see, this array and this array only differ at positions 1 and 2. This 2, 3, and this 3, 2, right? Because source starts with 1 and ends with 4. Target also starts at 1 and ends at 4, right? Or it starts with the 1 and ends with a 4. The only two positions that are different are right here, index 1 and 2. So since they differ at two positions and there are no allowed swaps, then the output is 2. Now, just in case that didn't make sense, let's take a look at example 3. So in example 3, our input source equals an array of integers 5, 1, 2, 4, 3. Target equals an array of integers 1, 5, 4, 2, 3. And allowed swaps equals a 2D array of integers 0, 4, 4, 2, 1, 3, 1, 4. The output is 0. Now, I'm not going to go through this whole explanation because there are just way too many swaps, because remember, we are allowed to swap elements at a specific pair multiple times in any order. So this is one of those examples where it's going to be a lot of multiple swaps. If you want to try to go through it on your own, I welcome you to do that, but we could just look at that like homework if you want to go through example 3. So now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, first thing we want to do is we want to get the number of elements. So we're going to say let n equal source dot count. Boom. Then we're going to union find the parent array, and initially each index is its own parent. So we're going to declare a variable called parent, and we are just going to set that equal to an array, open up the parentheses, and we are going to say 0 dot dot less than n. Boom. Now we're going to create a find function with path compression, and this is going to find the root of index I, or the representative of index I. So we'll come underneath this. We're going to create a func called find, open up the parentheses, we'll say underscore I, colon, that's going to be an integer. Come outside of that, it's going to return an integer, and we're going to open up the brackets. And if I is its own parent, then it's the root. So we'll say if parent is square bracket I equals I, then we're going to open up the brackets and return I. Boom. Now for path compression, we're going to flatten the tree for efficiency. So we'll come underneath this, and we are going to say parent square bracket I. We're going to come outside of that, set that equal to, find, open up the parentheses, parent square bracket I. Boom. Then we'll come underneath this, and we will say return parent square bracket I. Boom. Now we're going to build connected components using allowed swaps. So we're going to come underneath this right here. Sorry, y'all. And we are going to say for SN allowed swaps. We're going to open up the brackets, and we're going to find the root of the two indices by saying let R1 equal find, open up the parentheses, we're going to pass in O square bracket 0. Then we're going to come outside of that, say comma R2 equals find, open up the parentheses, S square bracket 1. Boom. And if they belong to different groups, we're going to union them by coming underneath this, and we're going to say if R1 does not equal R2, we're going to open up the brackets, and we're going to say parent square bracket R1 equals R2. Boom. Now we're going to use a dictionary to group values by their connected component, and the key will be the root of the component, and the value will be the frequency map of values and source within that component. So we're going to come underneath this. We're going to declare a variable called groups, set that equal to square bracket int colon, and then the value is going to also be an array of, the value is going to be a dictionary as well. So square bracket int colon int, then come outside both of these square brackets, and we're going to put parentheses. Boom. Then we're going to populate the groups with counts of source values. So we'll come underneath this, and we'll say for I in 0 dot dot less than n. We'll open up the brackets and let root equal find, open up the parentheses, pass in I. Then we're going to count occurrences of source of I in this component. By coming underneath that, we're going to say groups, square bracket root, comma, default, colon, square bracket, colon. Come outside both of those square brackets, open up some more square brackets, and we're going to say source, square bracket I, come outside of that, comma, default, colon 0, come outside of that, we're going to say plus equals 1. Boom. But we're still not done yet. Now we're going to create a variable that will store the final minimum handling distance by coming underneath this, and we are going to declare a variable called hamming this, set that equal to 0 just to start, and we're going to compare the target with the group source values. So we're going to say for I in 0 dot dot less than n, we're going to open up the brackets and we're going to say let root equal find, open up the parentheses, pass an I, come underneath that, we're going to say let val equal target square bracket I. Now, if this value exists in the same component and still available, we're going to come underneath this and we're going to say if let count equals groups square bracket root, come outside of that question mark square bracket val comma count is greater than 0, then we're going to open up the brackets and we're going to use one occurrence which will simulate a matching via swap. So we're going to say groups square bracket root, come outside of that exclamation point square bracket val. So we're going to set that equal to count minus 1. Boom. Then we'll come right here. We're going to say else, open up the brackets, and otherwise this position cannot be matched and it contributes to the Hamming distance. So we'll say Hamming dist plus equals 1. Boom. Then we're going to return the minimum possible Hamming distance by coming right here and we're going to say return Hamming dist, y'all. Boom. That should be all she wrote. Let's give it a run. Make sure it runs properly. Okay, we got an error. Oh, parent. This should be parent. So now let's run it again. Let's see. Allow swaps. Let's see, y'all. Let's see. Oh, sorry, y'all. This should be supposed to close this square bracket right here. Boom. So let's see if that did the trick. Okay, now we're down here. Need to add a G. Let's run that again. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 70 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the bottom. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.